Hello everyone, welcome to iQuanta. In today's video, we are going to solve some sets from CAT 19 slot 1 based on both logical reasoning as well as DI. Now when we talk about this LRDI section in CAT, it is getting tougher and tougher every year. So you should prepare religiously for this section as well as you should keep a target of solving around 500 plus LRDI sets before you attempt CAT 2020. Now to gain conceptual clarity in this section, you have to learn all the basic concepts in LRDI. After that, what you can do is you can start writing sectional mocks as well as full CAT mocks. You have to keep clearing your doubts regularly. And in parallel, what you can do is you can start solving past CAT papers as well as try to build up a strategy to make the right selection of sets. Because when it comes to the LRDI section of CAT, a major part of your performance, it depends upon the right selection of sets. And you can only develop this skill of choosing the right sets only after you write a lot of mocks and build up your own strategy for that. We have around 500 plus LRDI sets in our full course. So just in case you want to enroll for the full course, you can visit iQuanta.in. Apart from that, if you want to get any of your doubts solved for free, you can join the CAT preparation iQuanta group on Facebook. So now let us start solving this puzzle from CAT 19 slot 1. The question is, the following table represents addition of two 6-digit numbers given in the first and the second rows, while the sum is given in the third row. So we have a table over here in which we have two 6-digit numbers over here and they are being added and the sum is given in this third row. This is representing the sum. After that, in the representation, each of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 has been coded with one letter among A, B, C, D, E, F, G, H, J, K with distinct letters representing distinct digits. So every letter will be having a different value. Now in logical reasoning, you should always have a habit of representing the data. That data can be represented in form of a Venn diagram, a table, or in form of a graphical representation. So now in this question, we have to add these two 6-digit numbers and we'll be getting a number after the addition. Now whenever you perform addition, you always know that we start from the unit digit. So we'll be adding F, F, and it will be giving us a sum of F over here. So let us try to find out what are the possible values for F. See, if we add 0 and 0, we'll be getting a 0. If we add 1 and 1, we'll be getting 2. If we add 2 and 2, we'll be getting 4. If we add 3 and 3, we'll be getting a 6. Similarly, if you go till 9 plus 9, you will be getting 18. So in all the cases from 0 to 9, we can see that 0 is the only digit. When added to itself, it gives us the same digit 0. So that means all the other cases, they'll be cancelled. We can directly say that F will have a value of 0 over here. I hope this is understood. This was the very first step. So let me write down 0 in all the places where we have a F. So we'll have 0 over here, 0 over here, and 0 over here. We'll also have a 0 here and a 0 over here as well. Also, let me write F will be equal to 0. Now we can say that the value 0, it cannot be assigned to any other letter. Now while we add two numbers, we also see that sometimes there is a carry as well which is forwarded. But from here, there is no carry which is being forwarded. So if such a question comes, you always have to take care of the carry as well. Now after that, if we come to the tens place over here, we can see that G plus K, it will be giving us A. But we do not know what will be the value of G, K and A. There are many combinations possible. So let us try to avoid all these cases. What we can do is, if we directly go to this letter A over here, we can see that this A will definitely be a carry which would have been forwarded from here. And can you tell me what is the maximum value that a carry can take? Now here, when we talk about this carry A, it can have either there can be a carry or there will be no carry at all. So there will be a carry of 0 or 1. But if we assume a carry of 0, that means A will have to take value 0, which is not possible because F has already taken value 0 over here. So another possible value of carry A would be 1. Can we have a carry of 2 as well? No, it is not possible, because whenever you add two single digit numbers, the maximum carry that can be generated, it will always be 1. So that means A cannot be 2, it cannot be 3, 4, 5, 6, 7, 8, 9. So A will have a value of 1. Let me put A equals to 1. Now after this, if we directly go to this place over here, we can see that h plus h, it is giving us 0. So that means h is the same number which is being added to itself. So h plus h is giving us a 0. Now what can be the possible value of h over here? If I take 1 plus 1, this is not possible, we are not getting a 0. If we take 2 plus 2, again we do not get a 0. Similarly, if we keep moving on, we reach 5 plus 5, and that gives us a 0, and 1 will be the carry. It gives us 10, but we'll be writing only 0 over there, and this one will be the carry. Similarly, if you check till 9, you will not be getting 0 anywhere. So the only value that h can take, it will be 5. So let me write down h equals to 5. A was 1, h will be 5 from here. So we'll write 5 over here. Now if we come to these two letters G and K, we are getting 1 as the unit digit after the addition. So what can be the possible value of G and K? They can be 2 plus 9, they can be 3 plus 8, 4 plus 7, and 5 plus 6 is not possible because we have assigned value 5 to h. So these are the cases possible. These are the values possible for G and K respectively. But since here we can see that we have 1, 2, 3 cases, so it will be quite cumbersome to solve the question. We'll always try to avoid a situation where we have multiple cases. So let us move forward and try to find a situation where we have less cases. So if we talk about this particular column, we can see that B plus A is giving us A over here. A is 1, and we have this 1 over here as well, this one. So definitely this 1 is nothing but a carry, and we can see that above this B over here, we will be getting a carry of 1 from here as well. So we'll be adding this carry 1 as well, which is coming from the sum of h plus h. So basically we are getting 1 plus B plus A equals to 11 over here, or let me write it as 1 plus B plus 1. This is giving us 11. So what should be the value of B in such a case? It should be 9. So from here we can easily say that B will be equal to 9. So wherever we have B, I'll be writing a 9. We simply added this B plus A to get A here in the bottom, and we were already having a carry 1 from here over here. So let me write B equals to 9 in all the places. We just found it out. So B will be equal to 9. Let me write B equals to 9 here as well. So as soon as we get B equals to 9, we can cancel this case over here where we were getting G plus K equals to 2 plus 9, because now 9 cannot be assigned to either G or K, so this case will be gone. So now we can use these two cases for values of G and K. Now for G and K, we have two digits. They can be 3, 8 or 4, 7 in any order. If I start by assigning G equals to 3, K will be 8, G will be 3 over here as well. In that case, I'll be getting J equals to 2 over here. But that is not possible, because here we can see that C also has value 2, J also has value 2, and every letter should have a distinct value. So this case is not possible. Hence we cannot take G equals to 3, G cannot be equals to 3. Let us take G equals to 8 now. So if G is equal to 8, K will be equal to 3. In that case, a carry will come over here, which will be 1, and C will become 2. Since G is 8, G will also be 8 over here, and J must be equal to 7 over here. So this is a possible case in which each letter is having different values. So let me write one case over here, 951180, when added to 157030, it will give us a sum of 1108,210. I hope this is understood. So we are done with the 3-8 case. Now let me take this case of 4 7. Let me assign value g equals to 4 and k equal to 7. So if g equal to 4, k equal to 7, we'll get a carry over here. We'll be getting c equals to 2. Since g is equal to 4, we'll write 4 over here as well. In that case, j will be getting a value of 3. So yes, this is also a possible case because each letter is having a different value. So another number will be 951140 and 153070. It will give us a sum of 1104,210. Now let us make k equal to 4 and g equal to 7. So if g equal to 7, k equal to 4, we'll be getting a carry 1 over here. C will become 2. Since g is 7, so g will be 7 over here as well, and j will be given a value of 6. So yes, in this case as well, all are having different values. So another case will be 951170 and 156040, and we'll be getting 1107,210. So that's it. We have considered all the cases. Let us try to answer the questions. First question is, which digit does the letter A represent? So A is always representing 1. Answer will be 1 to this question. Let's solve the next question, which is, which digit does the letter B represent? So we have B at only one place over here. B is always equal to 9. So answer to the second question will be 9. Let's solve the third question. We have, which among the digits 3, 4, 6, 7 cannot be represented by the letter D? So we just have to check whether D can represent the digits 3, 4, 6, 7. So we have to check D for the value of 3, 4, 6, 7, and whatever value D cannot take, it will be our answer. So let us check all the cases. We can see that F always has a value of 0 in all the cases, A always has a value of 1 in all the cases, H always has a value of 5 in all the cases, B always takes value 9, C always takes value 2 in all the cases. We can see over here. When we talk about G and K, values that G can take, it can be 4 in this case, then in one case it was taking value 7, which is over here. In one of the cases G was taking value 8, and the corresponding values of K were, when G is equal to 4, K will be 7, when G is 7, K will be 4, and when G is 8, K will be 3. Now correspondingly, let us check the value of J as well. When G was 4, K was 7, then J was taking value 3 over here. When G was 7, K was 4, in that case J was taking value 6, and when G was 8, K was 3, then J was taking value 7 in this case. Now when we talk about this first case, G has value 4, K has 7, and J has 3. So in this case we have still two letters left, which are D and E. So they can take any digit out of 8 or 6 in this case. If we talk about this second case, 7, 4, 6, in this case D and E, they can take values 3 and 8. Then if we talk about this last case, 8, 3, 7, in this case I can say that D and E, they can take values 4 or 6. There are no other cases, and in all the cases we can see that D can never take value 7. You can check in all the cases. It can take value 3, 4, 6 in these cases, but not 7. So that means D cannot take value of 7. So 7 will be the correct answer to this question. Let's solve the last one, which is, which among the digits 4, 6, 7 and 8 cannot be represented by the letter G? So we have made the cases. Let us check them. We are talking about digits 4, 6, 7, 8 and letter G. So we can see that G can take values 4, 7 and 8 right over here in 3 cases. So that means G cannot take value 6. So 6 will be the correct answer to the last question. So I hope the puzzle is clear. We were having too many cases, but we learned how to cut down the cases and check all of them. If there is any doubt regarding this set, you can always ask. Thank you.